Welcome to our deep dive, everybody, into Nitinol.
Yeah,
It's a metal that can remember its shape.
that's right.
You bend it, twist it,
Yeah.
do whatever to it.
Right.
A little bit of heat.
Yeah.
It's like magic. It pops right back.
It is pretty amazing.
We're going to be looking at cocktail party chemistry,
Okay.
episode 53.
All right.
They had some awesome factoids in there.
Sounds good.
So, to kick things off, what exactly is Nitinol?
Well, Nitinol, it's a nickel titanium alloy.
Okay.
It's
Yeah.
pretty cool stuff.
So it's an alloy.
Yeah.
I mean, for people that might not know, like, what is an alloy?
An alloy is basically you're taking two or more metals
Okay.
and you're mixing them together to kind of get the properties
Oh, yeah,
of both.
Gotcha.
So so for Nitinol, it's nickel and titanium, hence the catchy name Nitinol.
Right.
You know.
There we go.
Yeah, so you're getting the strengths and benefits
Fluid, right.
of each of those metals.
Okay, cool. So it's not just like some ordinary metal then.
No, it's pretty special.
But when they say it remembers its shape, what does that even mean?
So think about like a paper clip, right?
Okay.
You bend a paper clip, it's bent, it stays that way.
Right.
With Nitinol, you can bend it,
Right.
deform it.
Uh-huh.
But if you heat it up,
Yeah.
it goes back to its original shape like it never happened.
Whoa.
Yeah, it's wild.
I've never heard of a metal doing that.
Yeah, no, it's pretty unique.
How is that even possible?
It's all about how the atoms are arranged, like inside the metal.
Okay.
It can exist in two different phases.
Okay.
So like think of water.
Right.
Water can be liquid.
Yeah.
It can be ice.
Right.
So Nitinol is kind of similar. It has these different phases where the atoms are arranged differently.
Okay.
And at lower temperatures, it's in this kind of deformed state.
Okay.
But when you heat it up, it goes through this transformation where the atoms rearrange themselves.
Oh, wow.
And it goes back to that original, like, preset shape.
That's pretty wild. Like
Yeah.
that is straight out of like, science fiction stuff.
It really is. It's pretty amazing.
So it's cool, but what's it actually used for?
Oh, man.
Like what are the things?
This is where it gets really interesting. I
Uh-huh.
mean, we're talking applications in medicine, robotics, aerospace.
No way.
Oh, yeah. Big time.
What kind of impact is this like having then right now?
Well, let's start with medicine, maybe.
Okay.
I think a lot of people have heard of stents.
Yeah.
Like, those little tubes they put in to help, open up arteries and stuff.
Yeah, I've heard of those.
So Nitinol is perfect for this.
Oh, really?
Yeah, because you can actually insert the spent in this like compressed form.
Okay.
And then when it gets to where it needs to be, the body heat triggers the shape memory effect. And it expands to the size it needs to be to open up that artery.
So it's like a self-expanding, like, I don't know, like scaffolding or something like that.
Exactly. Like a self-expanding scaffold for your arteries. That's a great way to put it.
Wow.
Yeah, and it's not just stents either. I mean, they're using Nitinol for braces, like to straighten teeth.
Oh, yeah.
Yeah. And even in surgical instruments, like, during surgeries.
Wow. So it's like literally saving lives,
Mhm.
improving people's health, this metal.
It really is. It's pretty remarkable what they're doing with it.
That's wild.
Yeah.
But that's just medicine.
Yeah, we've got robotics and aerospace to talk about.
Yeah. What about like robotics?
So, robots, they need to be tough,
Yeah.
especially if they're working in like hazardous places.
Right.
So Nitinol can be used to create these self-healing mechanisms in robots.
What? Self-healing robots.
Yeah. It's pretty wild. So like if part of the robot gets damaged, it can actually like repair itself using this heat activated shape memory effect.
Like, so you heat it up and then it just like fixes itself?
Pretty much, yeah.
That's insane.
It's pretty cool.
That is so cool.
It's still early days, but there's a lot of potential there.
Okay, so robots that can heal themselves. What about aerospace?
So space travel, it's all about being lightweight and compact, right?
Yeah.
Got to fit everything in the rocket.
Right.
Nitinol is great for this because you can create these structures that can fold up really small.
Okay.
And then when they get to space,
Yeah.
they can expand using, again, that heat-activated shape memory.
Oh, wow. So like antennas, solar panels, stuff like that?
Exactly, yes. Like imagine like huge solar arrays,
Yeah.
all folded up,
Yeah.
nice and compact for launch,
Uh-huh.
and then boom, once they're in space, they unfold.
That's amazing.
Yeah, it's like space origami,
Yeah, like self-assembling stuff in space.
Exactly.
That's pretty crazy. I mean, this is like like world-changing stuff, this
It
Nitinol.
really is. It has the potential to be, yeah.
It can't all be like sunshine and roses, though. Like, are there any downsides to it? Any limitations?
Well, of course, like any material, there are some trade-offs. One of the biggest ones is cost.
Okay.
Nitinol can be pretty expensive to manufacture compared to, like, your typical metals.
All right, that makes sense. So cost is one thing. What else?
And it's not, a solution for everything. Like, there are temperature limitations, for example.
Huh.
If it gets too hot, you can lose that shape memory effect.
Gotcha.
So engineers have to, like, really carefully consider if Nitinol is the right material for the job, for each specific application.
Right. So it's like anything in engineering, right? You got to
Yeah.
weigh the benefits
You got
against the drawbacks.
Yeah, got it.
Okay. Well, this has been like a mind-blowing overview so far.
Oh, good. I'm glad.
But you mentioned earlier that Nitinol was discovered at the Naval Ordnance Laboratory.
Right.
What's the story there? Like, how did someone find this stuff?
It's a great story, actually. It was a total accident.
Oh, no way.
Yeah. Back in the early 1960s, there was this metallurgist.
Okay.
His name was William Bueller,
Okay.
and he was working on, trying to develop new materials for submarine hulls.
Okay.
So he was experimenting with all these different metal alloys,
Right.
and one day he noticed something really weird.
Okay. I'm on the edge of my seat. What happened?
So he had this sample of this nickel titanium alloy.
Okay.
And he had bent it all out of shape.
Yeah.
Totally deformed it.
Right.
And then just by chance, he heated it up.
Okay.
And to his absolute astonishment, it sprang right back to its original shape.
Bro.
It was like magic.
So he discovered it by accident.
Pretty much, yeah.
Yeah.
It was a total fluke. But, he's smart enough to realize, hey,
Yeah.
this is something special.
That's amazing. It's crazy how some of the biggest discoveries are just total accidents.
Yeah, sometimes you just got to be in the right place at the right time.
Yeah.
And be paying attention.
Yeah, be like, wait a minute.
Exactly.
That's not normal.
And in this case, that little accident has led to, this incredible material that's changing the world.
It's pretty awesome. Well, I'm definitely excited to dive deeper into this specifics
Yeah, me too.
of how Nitinol is being used.
Absolutely.
And kind of explore, what the future holds for this amazing material.
There's a lot to talk about, that's for sure.
Yeah.
So where should we start?
Well, I guess let's get right to it then.
Okay, let's do it. That was a really cool story about how Nitinol was discovered, just a total accident.
It makes you wonder, what other kind of cool materials are just waiting out there for us to stumble upon.
Totally.
But I guess for now, we'll stick with Nitinol
For now, yeah.
and dive into the specifics.
Yeah, let's get into some actual applications.
Yeah. How is this actually being used?
Right.
We touched on medicine,
Yeah.
robotics, aerospace.
Uh-huh.
What are some real world applications
Okay.
for this shape-shifting metal?
Well, let's stick with medicine for a second.
Okay.
Because I think that's where a lot of people are seeing the benefits right now.
Yeah.
Stents are a big one.
Okay.
So for people who don't know, a stent is this little tube
Right.
that they can put into a blocked artery,
Okay. Yeah.
and it helps to open up the blood flow.
Right. We talked about that earlier a little bit.
Yeah.
But how does the Nitinol actually change things?
Right. So what's cool is that they can insert the stent in this really small compressed form, and then once it's in place in the artery,
Yeah.
the body heat actually activates the shape memory,
Wow.
and it expands to the right size to prop open that artery.
That's so cool.
Yeah.
That's incredible that something so small
I know.
can have such a huge impact.
It's pretty amazing, yeah. And what's also really important here is that Nitinol is biocompatible.
Okay, yeah. What does that mean?
Basically, it means that the body doesn't reject it or react badly to it.
Gotcha.
So, you don't want to put something in the body that's going to cause problems.
Right.
So Nitinol is really good for that.
So it's safe.
It's safe, yeah.
And effective.
Exactly.
Right.
And it's not just stents either. They use Nitinol in some braces for your teeth.
Oh, yeah.
So, to help straighten teeth.
I can see how that gradual force would be really good for that.
It's perfect because, you can program it to exert a very specific gentle pressure over time to gradually move those teeth.
That's amazing. What about those surgical instruments you were talking about?
So Nitinol is being used to make these like really cool new surgical instruments that are super precise and flexible.
Right.
One example is laparoscopic graspers.
Okay.
So these are used in minimally invasive surgery.
Okay.
So like when they go in through tiny incisions, and Nitinol is great for this because it can bend and flex. Okay. So it can get into these like really tight spaces.
So you don't have to like open someone up as much.
Exactly, yeah. Less invasive.
Wow.
Faster healing times, all that good stuff.
So it sounds like it's really transforming like the surgical landscape.
It really is, yeah. It's having a big impact.
Wow. Okay, so we've got medicine covered.
Okay.
What about robotics?
Robotics, yeah. So, you mentioned earlier, like, self-healing robots.
I know, that sounds like right out of a movie.
I know, it sounds crazy, right?
Yeah.
But it's becoming a reality.
Really?
Yeah. So one of the ways they're using Nitinol is in actuators, which are basically like the muscles of robots.
Okay.
So, traditionally you'd use like motors and hydraulics to move things.
Yeah.
But with Nitinol, you can create these like really lightweight, compact actuators.
And they're powered by heat.
Yeah, they're triggered by heat. So you can use like electrical currents to control the ShapeMemory effect and create motion.
So these robots can like move really precisely then.
Yeah, and they're super responsive.
And they can heal themselves. If they get damaged.
Yeah.
Like that's insane.
Yeah, it's pretty wild.
Like think about like search and rescue. Sending robots into dangerous places.
Yeah.
That's incredible.
Lots of potential there.
So we got medicine, robotics.
All right.
What about space?
Space, yeah. So space travel, like one of the biggest challenges is, launching these huge structures like, solar panels, antennas, things like that.
Got to get them up there somehow.
Yeah, and they take up a lot of space.
Right.
So Nitinol is great for this.
Okay.
Because you can make these like deployable structures that can fold up really small for launch.
Right.
And then once they're in space, they can expand to their full size.
That's cool.
Yeah.
So it's like, compact for launch and then boom, there it opens up.
Yeah, it's like space origami or something. Self-assembling structures.
It's crazy. Like what are some specific examples of that like in space?
Well, like antennas for satellites, for example. So, they can launch the satellite.
Yeah.
And then the antenna can deploy once it's in orbit.
That makes way more sense.
Right.
Than trying to launch it with the antenna already out.
Exactly.
Yeah. Okay.
And they're also looking at using Nitinol for solar panels.
Oh, wow.
For spacecraft.
Like those big, arrays, but they could fold up.
Yeah.
Wow. Okay. So it's like making space travel more efficient.
Yeah.
More cost effective, I guess.
Exactly. Yeah. I mean, it's opening up a lot of possibilities.
So we've talked about medicine, robotics, aerospace.
Right.
Is it limited to those fields? Or are there other areas where, it's being used or people are looking at using it?
Oh, no. Nitinol it's popping up everywhere.
Really?
Like there's a lot of research going on in the energy sector.
Oh, wow.
For example, so, people are looking at using it to create devices that can harness energy from like temperature fluctuations.
Like how does that work?
So imagine a device that can capture like waste heat.
Okay.
From industrial processes or even like car engines.
Oh, wow.
And Nitinol can be used to create this component that expands and contracts with the temperature changes. Wow. And that motion can be used to generate electricity.
Wow. So you're talking like clean energy.
Yeah, potentially.
Yeah, that's a really cool idea.
Yeah, there's a lot of potential there. And another interesting area is microfluidics.
Okay, microfluidics, what's that?
So microfluidics is basically like the science of manipulating really tiny amounts of fluids.
Okay.
So like at a microscopic level.
Right.
And you can use Nitinol to create these like tiny valves and pumps that can control the flow of these fluids.
Okay.
Through like really small channels.
So it's like controlling like drops of liquid or something like
that. Yeah, very, very precisely.
Wow, what would you even use that for?
Oh, tons of stuff. Yeah. Like, lab-on-a-chip devices for medical diagnostics, drug delivery systems, where you can, like, release medication really precisely.
That's like straight out of Star Trek or something like that.
It's pretty sci-fi.
Wow.
Yeah.
It's amazing we can like control fluids that precisely, at that scale.
Well, it's pretty mind-blowing when you think about it.
Yeah. It's like Nitinol's like a Swiss Army knife of materials.
It kind of is, yeah. It's got so many different uses.
It's wild. So we've talked about all these benefits.
Yeah.
But you mentioned earlier, like, one of the biggest challenges is cost.
Yeah.
Can you talk a little bit more about that? Like, why is it so expensive to produce?
Well, I mean, a couple of things.
Okay.
First of all, the raw materials, the nickel and the titanium, they're not cheap.
Right.
Compared to like, steel or aluminum, which are like the more common metals.
Right.
And then the manufacturing process it's pretty complicated, to get the right properties.
Yeah.
You need to have very precise control over the composition heat treatment.
Right.
So it's not like, something you can just like whip up easily.
Right. It's specialized.
Yeah, it's specialized.
So it requires specialized equipment.
Right.
Expertise, so that all adds to the cost.
Exactly. Yeah. So it's a high-tech material,
right,
and it comes with a high-tech price tag.
But you mentioned like the cost might come down as demand increases.
Yeah, that's the hope.
Manufacturing gets better.
Yeah, I mean, like any new technology,
yeah,
as it becomes more widespread,
right,
as production scales up, the price tends to come down.
Right. Okay. Yeah.
So hopefully we'll see that with Nitinol as well.
That would be awesome.
Yeah.
Because that would open it up to so many more applications.
Exactly.
Besides the cost, are there any other like hurdles to overcome?
Well, one of the things is predictability. So like the ShapeMemory effect it's pretty reliable.
Yeah.
But it can be influenced by things like temperature, stress, fatigue.
Right.
So, scientists are still working on really understanding how all these different factors affect Nitinol's behavior.
So we can like predict exactly how it's going to act.
Exactly. Yeah, because you want to make sure that it's going to do what you expect it to do.
Right.
And then durability is another big one.
Okay.
You want to make sure that these Nitinol components can withstand like repeated cycles of deformation and recovery. You don't want it to wear out.
Right. Like a stent. You don't want to just like stop working after a couple of years.
Exactly. Yeah. So they're working on improving the fatigue resistance of the material.
And you mentioned like the manufacturing could also be improved.
Yeah, definitely. I mean, finding ways to make the manufacturing process more efficient, more cost effective.
Right. Because right now it's
complex. It's specialized.
Yeah.
But, there are new technologies coming out like additive manufacturing, 3D printing.
Yeah.
Which could potentially be used to make Nitinol components.
Oh, wow.
Yeah.
That's really cool.
Yeah. So there's a lot of exciting developments happening.
It sounds like the future for Nitinol is pretty bright.
I think so, yeah. Lots of potential.
Yeah, I mean we've learned so much today.
Yeah, it's been a good discussion.
I feel like I have a whole new understanding of this crazy material.
It is a pretty crazy material.
And its potential, to shape the future.
Absolutely.
Before we wrap up though, I want to leave our listeners with one final thought.
Okay.
We've talked about all these existing applications, potential applications for Nitinol. But if you could design anything with this metal that can remember its shape.
Oh, wow.
What would it be? What problem would you try to solve?
Oh, man. That's a tough one.
I know. It's a good question.
It's a good question. Let me think for a second.
Okay. Have you come up with something? What are we thinking?
Okay. So I was thinking about, amputees.
Okay.
And the challenges they face with prosthetic limbs.
Right.
And I was thinking, what if you could use Nitinol to create like a really advanced prosthetic?
Okay.
Like one that could actually like adjust its shape and stiffness.
Whoa.
Based on, what the person's doing.
Like so if you're running versus, I don't know, like walking on sand or something.
Exactly. Yeah. Like imagine a prosthetic that could adapt to different terrains, different activities.
Wow. So how would that even work?
Well, you could use like Nitinol actuators.
Okay.
And sensors.
Yeah.
So it could like sense the pressure and movement and then adjust the shape of the limb accordingly.
That's crazy. That would be so cool.
Yeah, I think it would be huge for people with limb differences.
It would be life-changing.
Yeah, it would give them so much more mobility.
Yeah.
Freedom.
Yeah, like freedom of movement that they don't have right now.
Exactly. And that's what I think is so exciting about Nitinol is that it really has the potential to create these like really innovative devices that can really improve people's lives.
It's crazy to think that something that started, as an accident in a lab.
I know, right?
Is now being used to do all this stuff. Like that can help people so much.
It's pretty amazing how these things happen.
It really is. Well, I think that's a fantastic note to end on.
Yeah, I like that.
Our deep dive into the world of Nitinol.
Yeah.
We covered a lot today.
We did, yeah.
From the basics, what is Nitinol to all these like mind-blowing applications in medicine, robotics, aerospace, energy. I mean, who knows what else is coming down the line?
Who knows? Yeah, the future is wide open.
It's exciting. Hopefully our listeners have a new appreciation for this material.
I hope so too.
And maybe one of them will be the one to come up with the next big thing for Nitinol.
I would love to see that. That would be awesome.
Thanks for joining us. And until next time, keep those minds curious.
Yeah.
And keep exploring.
Absolutely.